Okay, it's challenge time again. Imagine you work for a company that has employees from around the world and you need to find an hour of time to schedule 2 employees to meet. The meeting should be on a workday, Monday through Friday, and between the hours of 7 a.m. and 9 p.m, meaning the meeting should not be scheduled any later than 8 p.m. for either employee. One of the employees is on the east coast of the United States, the other is in Sydney, Australia. Print all the possible hours in the upcoming 10-day range, ignoring the current day, when these 2 employees could potentially meet together. Print the date and time of each possible hour for both zones, using the employee's locale. The example output on this slide demonstrates what one possible hour would look like, and the dates formatted to the employee's locale. In my example, Jane is the employee in the US, and Joe is the employee in Sydney. Include the weekday in the output, and the hour using AM or PM, rather than a 24-hour format. Pause the video now and try that out. Once you are done, come back and compare your solution to mine. Okay, so how'd you do? Were you able to figure that out on your own? Let's walk through this together and see one way to do this with some of the tools you've learned to date. I've created a new project called Datetime Localization Project, and I'm starting in the main class as usual. The first thing I'm going to do is create an employee record that will link my employee with both a locale and a time zone. This wasn't part of the challenge, but this is one way you could keep this data associated with each employee. I'm going to make this a nested type in the main class, and I'll just make it a private record named employee. It'll have 3 parameters, a name, so string, a locale, and a zone, and I want to use the more recent recommended time zone class, so zone ID. For this record, I'll set up some custom constructors to create employees with either a locale string or a locale object. I also want to just pass a string for the zone ID, rather than have the client have to construct a zone ID object. I'll create a custom constructor and pick all 3 fields. First, I want to change the zone ID to be a string instead. I'll next remove the 3 statements that were generated and instead make a call to the canonical constructor. I'll pass name locale, and in this call, I'll use zoneid.of and pass that the method argument zone. I'll copy this constructor code, pasting a copy above this one. I'll make locale a string for this one. I'll use the method for language tag on the locale class to create a locale based on the string that gets passed to this constructor. I'll add one more method here to print a date in this employee's locale and time zone. I'll make this method package private since nobody outside of the main class needs access to it. I'll return a formatted string with the employee name, the zone they're in, and the date, using the formatter passed to the method, but localized to the employee's locale. Now I can keep track of all the info I need for each employee. I'll go to the main method next and set up a couple of employees. I've said that one employee is on the eastern coast of the US, so I'll call this employee Jane. I'll pass the name Jane, the static field that's locale.us, and the zone ID, which I've said previously is America/New_York for the east coast of the US. Next I'll do the same thing for an employee named Joe, and this time I'll pass in the string EN-AU. For the zone, I'll pass the zone ID Australia/Sydney. It might be interesting to first know how many hours difference there are between these 2 employees. I'll set up 2 more local variables for the zone rules for each of these employees. First, Joe's rules, and I'll assign that joe.zone.getRules. I'll do the same here, but call it Jane's rules and use jane.zone.getRules. I'll print the employee Jane and her rules. And the same for Joe. If I run this code, I can see that the locale and zone ID instances were constructed correctly for both Jane and Joe. I can also see the UTC offset for each employee in the rules output. By this reckoning, Joe and Jane are 15 hours apart on the clock. But is that really right? I can test that out by using the between method on the duration class. First, I'll set up an instance of a zoned date time called JaneNow and construct that with the now method on zone date time passing it Jane's zone. I can create another zone date time using the exact same time as Jane's time. In this case, I'll make a call to local date time on JaneNow as the first argument and Joe's zone as the second argument. I'll use the between method on duration, first passing it these two zone date-time variables to get a duration, and I want to know how many hours that is, so I'll use 2 hours. I'll get minutes as well, partial minutes in this case, using the 2 minutes part method on that duration class. Remember I said that some parts of Australia are also on a half hour or quarter hour additional offsets, so I don't want to lose that information, if that's the case. I'll print how many hours and minutes Joe's is ahead or behind Jane's time. Since Joe is to the east of Greenwich time, he'll always be ahead of Jane. Running this code, I'll get that Joe is 14 hours 0 minutes ahead. This is the result of the additional daylight savings rules for one of these two regions. Let's change Sydney to Eucla in the Joe variable to see what changes. Running this code now, the output now shows that if Joe lived in Eucla, he would only be 12 hours and 45 minutes ahead. Again, you might get a different result depending on the time of the year you run this code, taking daylight savings into account. I'll undo that last change, and before I continue, I want to use a couple of methods on the rules variables. I want more information about which employee is actually in daylight savings time and the rules for that. First, I'll print out some text. Is Joe in daylight savings ? I'll print out the result of calling the method is daylight savings on Joe's rules, passing that an instant I get from the Joe now variable. After this, I'll print the adjustment data for that time. Finally, I'll use a date-time formatter pattern to print the daylight savings information, first the long text, so at least 4 Zs, and then the short text, so a single Z will do that. Before I go on, I'm going to simplify my code so that when I use any of datetime formatter's static methods, I don't have to qualify the method with that class's name. First, I'll remove datetime formatter and the period from the last statement. Now, if I hover over the method of pattern that is showing an error, I can select Import Static Method. When I do that, if I scroll up, I'll see the static import method has been included in my list of import statements. I'm going to change this statement to import all the static members of datetime formatter using the wildcard. Next, I'll copy those last 4 statements in the main method and paste that copy just below. I'll change Joe to Jane in every case, so first in the text that's printed. I'll change Joe to Jane in the 2 variable names on the next line and also the line that follows that. And I'll change that last variable on the last line to be Jane now. When I run this code, depending on what time of year I run it, I may get false or true for either employee, whether they're in daylight savings or not. That's usually the opposite for these employees because of their locations. When Sydney is on daylight savings, the east coast of the US usually isn't, and vice versa. You can see after the Boolean value the period of time that would get adjusted, so PT0S, 0 seconds, or PT1H, 1 hour. That's then followed by the name and code of the daylight savings time. So for Sydney, that's Australian Eastern Standard Time, AEST, and for the US, it's just Eastern Daylight Time, or EDT. Okay, so that was just a little additional review. Now I want to dig into the goal of this challenge to identify the hours in the day that these two employees can meet. I'll first set up a private static method that returns a map. That map will be keyed by a local date, so only the date there, and it will have a list of hourly slots, or zoned date times. I'm calling this method schedule. It will take my 2 employees and the number of days I'll search ahead for matches. Next, I'll create the rules to select which hours and days to match on as a predicate. This is because I'm going to use streams to create these hourly slots, and I'll use this predicate to filter out hours that don't work for each employee. If you were building this for real, you might have these rules be part of your employees' data and be based on the hours they actually do work, etc. For this challenge, the rules are the same for both employees. The day of the week of the meeting hour can't be either a Saturday or Sunday. And the hour can't be less than 7 AM or more than 8 PM. So using a 24-hour clock, I'll say the hour has to be less than 21. Before I start my stream, I'm going to set up a local date variable called starting date using localdate.now, but I want to add 2 days to that. If Joe is 14 hours ahead, and this depends on what your local date really is, I don't want to schedule any meetings for the current day, so I really need to add those 14 hours plus another 24 to meet that requirement if I'm based in the US, for example. Adding 2 days will prevent scheduling either employee for their current day. I'll use a stream to figure this out. Remember, local date supports the dates until method that returns a stream of local dates. I'll pass that days plus 1, so I'll get a stream of dates that start with the starting date and continue for the number of days passed to this method. Now I want to get a zone date time using my first employee zone, but starting with the 0 hour of the day, which I can do with the method at start of day on local date. I'll call flatMap here, starting with another stream for each hour in the day, so an int stream with a range of 0 to 24. I'll map each integer to a zone date time using the with hour and the date passed in. So for each day, I'll have 24 possible hours to start an hourly meeting. I could have made the hours 7 to 21, but I really want to keep this code separate from the rules in case those change or are customizable by employee in the future. I'll filter these hours with my custom predicate. Now, I'll change the zone date time to the second employee's date and time for this same instant. Remember, an instant is UTC based. I'll again filter this new date time with the same rules I set up. Finally, I'll collect these into a map that I'll be returning from this method. I'll key by the local date for the second employee. I want to use a tree map. Dates have a natural order, so I can use this simpler method reference as the supplier code. Finally, my map value is a list of the matches or the hourly zoned date instances that match both employees' requirements. Okay, that's it for the scheduling method. That's weird, that tree map is not found by IntelliJ. I will sort that out shortly. To execute it, I'll first set up a local variable in the main method. I've said I want to check 10 days ahead, so days equals 10. I'll call the schedule method, passing first Joe, since he's ahead on the clock, then Jane, and my days variable. I want each hourly slot to be formatted using the full style for the date and the short style for the time. The of localized date time should have been found by the wildcard I added earlier on the static import. Let me double check that. Well, that is strange. I was pretty sure I changed it to a wildcard. Let me do that again, which should resolve of localized date time. Now that is resolved. Let me sort out the tree map problem. Tree map is still not found, so let me type it again and then manually add the import with control space. Okay, that worked. A bit of a weird one there. Let me go back up to the main method now. Here I will add an enhanced for loop, looping first through the resulting map's keys. It's actually keyed by Jane's local dates, since she was the second employee passed in, and the stream used the second employee's local date in the grouping by statement. I'll print this date using format style.full. You may have to again import static for the method of localized date if IntelliJ is automatically updating your import statements, or you can go back up and change the imports to a wildcard if need be. Next, I'll loop through the list of zone date times that the scheduler found matches for. I'll print a tabbed indent. I'll call Jane's getDateInfo method, passing it the current zone date time and the date time formatter variable DTF. Next, I'll call Joe's getDateInfo method, but I want to pass Joe's own zone date time, so I have to transform it, and I'll do that with the method with zone same instant. Now, if you run this code, depending on what day of the year you run it, you should see some valid overlapping hours for these two employees. Jane's will be printed out using the US locale, and Joe's the Australian locale. There are some differences. For example, in the US, the month is usually printed before the day of the month, and in Australia, it's the other way around. Okay, so that was the challenge. I hope this walkthrough helped a little. You can see I started out with a stream of local dates, which I then transformed into a stream of hourly zoned date times. I was able to use the same predicate to test the same rules for both employees' zoned date times and get a map of all possible hours that match the rules I set out. Again, there were a lot of ways to do this without streams, but I did want to use the dates until method I discussed in previous videos. In the next video, I'll be introducing you to internationalization using the resource bundle class. So let's move on to that.